Okay guys, we are going to be doing 8.4. There's actually a few things that are going to be going on here in 8.4, but let me give you a few definitions. What we're going to be looking at today is talking about the angles in standard position. So here's a specific coordinate grid. Notice that, remember when we were doing the unit circle yesterday, that as you go around a circle, you've got the 0, 90, 180, 270, 360, and that's what's going on here. Is you have to just imagine it's just a big circle that's going around. This side right here, on this side of the x-axis, that is called the initial side. That does not move. Now, notice that you have the origin, which we know is going to be right here, right? This side right here is called the terminal side. And that is going to rotate. So, of course, if I was standing in front of you, I would be taking my hands and then I would say, okay, here I am. I'm rotating my arms around and around and around. And so as you rotate in a circle, you're forming some kind of an angle. That's going to be our theta. Okay, remember theta from 8.1. Theta just means angle measure. And so what we're doing is we're looking at where are you going as you go around in your circle. What is the angle that's being formed? Well, notice in this particular example, notice this red arrow here, and as it's going around, notice it's pointing in this direction. This direction right here, because oftentimes you have to know which way you're going, we call that counterclockwise. That is if your theta is greater than 0. If your angle measure is greater than 0, positive, if you want to look at it that way, is a positive number, you're always going to be going in the direction of counterclockwise. Now, contrary to that is your opposite of that, right? So if I had a term, let's say here's my initial side. Actually, I'll do this. Right? So there's my initial side. It hasn't moved. And then I take it and I go this direction. Let's just say I come down here. And your arrow is stating that, oh, I went in this direction here. Well, that is clockwise. And that is going to be if you have a negative degree. So if theta is less than 0, or you can think about it as if it's a negative number. Now, both of these, actually I didn't put any numbers on this one, but this was in degrees. Well, you're also going to have the same thing in radians. Remember, 90 degrees is the same thing as pi over 2. 3 pi over 2 is the same thing as 270, and so on and so forth. So this is the exact same thing. So as an example, if I wanted to draw, let's say, pi over 4. Pi over 4, if I used my unit circle here, is the same thing as 45. I may not know what pi over 4 looks like, but I know what 45 degrees looks like. 45 degrees is going to be halfway through that quadrant, and I would draw it this way, and I would make sure that I state that I'm going in this direction here because I said positive pi over 4, and that would be my pi over 4. So that would be what it would look like there. Okay, so just know you may have it in degrees, you may have it in radians. Now, as a general rule, when your problem starts in degrees, you end it in degrees. If your problem starts in radians, you end it in radians. Even though I switched this to degrees to look at what my angle looked like, I still am going to put my final answer as a radian, and that's what I'm actually saying. All right, so let's move to the second page. And I bled through a little bit here, so let me do this. Okay, so as an example, all we want to do is state what quadrant it's in. So just if we take a second and actually let's do this. Let's go back to this for a second. remember, when you have a coordinate grid, and we can look at any of these here, remember this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Then you have your x-axis and you have your y-axis. So when the directions say which quadrant or on which axes does the terminal side lie, remember that's the part that's moving, then you're going to say either 1, 2, 3, 4 or x-axis, y-axis. So pi over 5, personally, I am the most comfortable with degrees. I'm not exactly sure where pi over 5, well I do, but I'm pretending to be you. If I were a student, this is all kind of new to me, so I would probably feel more comfortable in looking at degrees. So if you remember in the last lesson, I taught you how do you go from degrees to radians, how do you go from radians to degrees. Well, remember, to go from radians to degrees, you're going to multiply by 180 over pi, and we can reduce that. And 5 goes into 180, let's see, 5 into 18 3 times with 3 left over, and so that's going to give me 36. So I know that pi over 5 is 36 degrees. Well, if I take a look at where that would land, remember here's 0, 90, 180, 270, 30 degrees, here's my initial side, 36 degrees would land maybe, ooh, that's kind of big, maybe about here. Now what quadrant does that lie in? That lies in quadrant 1. Okay, let's try the second example. 7 pi over 5, let's go ahead and change that to a degree. Cancel, cancel. We already know that 5 goes into 180 36 times, and I'm going to multiply 36 times 7. So let's see, what is that? 36 times 7. I'm just being lazy here. It's 252. Oops. Okay. All right, so 252 degrees. So where would that lie? So once again, I'm looking at, oh shoot, I wrote 36 degrees. Well, I guess the answer is just quadrant 1. That's really the only answer. I was going to say I would have gone back and wrote it as a radian. Where does 252 degrees lie? So we know, remember, there's 0, there's 90, there's 180, there's 270. So we know it's going to be falling somewhere in here, probably around here somewhere. Remember, here is your side and going in the positive direction. We landed here. Okay, so what quadrant is that? 1, 2, 3. So the answer would be quadrant 3. Okay. This is the part of the class where I would say, okay, I want you to try this one on your own. And then don't forget, you also have that unit circle. You may find some of these once in a while might fall on the unit circle. 5 pi over 4. So I'd always look at it. I happen to know that these don't fall on the unit circle, but this one, it does, and you can always double check until you start to see these numbers. 5 pi over 4 is the same thing as 225 degrees. Right? So if I'm looking back up here at this diagram here, 225 degrees, once again, is going to lie between 180 and 270. So the answer would be quadrant 3 for that one as well. Okay? So the first part of your homework is just simply taking either radians or degrees and saying what quadrant does it lie in. And if it's in radians, it might be a good idea to change it to degrees, just because that one's a little bit easier to work with. All right, and let's do a couple examples using degrees. So this one says, in which quadrant or on what axis does the terminal side of the angle lie? Once again, we're looking at, now we're in degrees. So I'm going to go ahead and just draw it. So 0, 90, 180, 270. Now, what does the negative mean? Think about what that meant, right? Remember, the negative means you're going to go down the clockwise direction of 30 degrees. Okay? So that would be negative 30 degrees right here, because remember you always start at 0 and we're going to go down 30 degrees going in this direction here, which lands us in 1, 2, 3, 4. The answer would be quadrant 4. Okay. 250 degrees, I feel like we just did that on the last slide, or at least we did one that was very close to that. 252 degrees is going to still land in the same spot there. Notice there is a positive, so we know that it's going to go land right here, somewhere in that area right there. Once again, that's going to be quadrant 3. Okay. All right, so that's the first thing, is just looking at what quadrant the angles lie in. The second thing we're going to do is talk about something called a coterminal angle, and this is a definition. Really what a coterminal angle is, an angle whose terminal side coincide. In other words, they look exactly the same. So here's an example. Let's do this one first. If I were to sketch the graph of 150 degrees, so there's 0, 90, 180, 270. 150 degrees would be somewhere in here, right? So we would take, here's my initial side, and I'm going to rotate maybe about there somewhere, right? Maybe a little further. Okay. And that would be 150 degrees, okay? Now let's do 510. Well, how the heck are we going to do 510? There's only 360 degrees in a circle. So here's how it works. Okay, so what you're going to say is 510 degrees, if you have your angles here, starting here at your side, is you're going to go around one full rotation. That's 360 degrees. Well, we want to go to 510, so we're going to go another 150 degrees, right? Because 360 plus 150 is going to give you 510, and there is your 510 degrees. Now, if I were to erase the red mark and erase the red mark here, would these angles look exactly the same? That's what coterminal angles mean. Coterminal angles are angles who look exactly the same. It's just you may have had to go another rotation. You may go back the opposite way, that type of thing. So really, the easiest thing to do to find coterminal angles is to simply add 360 degrees to the angle. So if I added 150 plus 360, guess what I would get? 510, right? So it says name 4 coterminal angles for 310. So I would take 310 and I would add 360 to that. And if I do that, I'm going to get 670 degrees. That is one coterminal angle. And then we could go around again and again and again, and I think you see where I'm going with this. But you're just simply going to keep adding 360 to each of those. So there would be another one. And we could do it one more time if I wanted to. So now we're at 1030. And we're going to add 360. And I'm going to get 1,390. Now that's only 3. What if it says, okay, yeah, but I want one negative? You see how it says I want one negative? Well, remember, there's 2 directions you can go around the circle. If I start at 310 and I go in the negative 360 direction, in other words, if I go clockwise, I could take my original angle and subtract 360, and that would also give me a coterminal angle of negative 50 degrees. And so there would be my 1, 2, 3, 4 coterminal angles. So it's really, really simple. You just add 360 or subtract 360 to get your coterminal angles. All right, so let's see what's next. Page 3. Oh, I'm sorry, not page 3, 4. I think I went out of order here, didn't I? Because this is page 2. So I think I went out of order, guys. Oh well. Hey, you're learning though. Well, it all kind of goes together anyway. Okay, so hopefully I'm back on track. Sorry about that. So now, this is an example of the homework. We want to sketch the angle in standard position. Negative 20 pi over 9. So the easiest thing to do is put it as a degree. Okay. However, since we're graphing this, when you go to do your axes, you want to do it in terms of pi. So this is 0, and then you've got pi over 2, and then we've got just pi, and then down here was 3 pi over 2. And if you're not sure, I'm getting those off of the unit circle. Just label your axes, okay? And then if you wanted to write that as 2 pi over here, you could as well. Okay. Now, even though I wrote them as radians, I'm going to go ahead and figure it out in degrees because I kind of have an idea where to go in degrees. So I'm going to take my negative 20 pi over 9 and I'm going to change that to radians. I'm sorry, to degrees. Okay, so my pi is going to cancel. 9 goes into 180 20 times and I get negative 400 degrees. Now, I know that one full rotation around the circle is 360, so I'm going to go 360 and then add another 40. But what direction am I going to go? So what you're going to do is you're going to draw what we call the spiral. The spiral part is very important part of the graph because that tells you that you had to go a rotation. So if I start here at 0, I'm going to go in the clockwise direction. I am going to go 360 degrees, and then I need to go an extra 40 more degrees, which is going to land me maybe about there. Now this is all just approximation. I'm then going to draw my tiny little arrow there, and there would be my answer. Okay, so that would be negative 20 pi over 9. Okay. This red spiral is very important. Please don't forget your spirals on your assignments. All right, we're getting down to the last thing I wanted to talk about, and that is called reference angle and then how we find the reference angle. Reference angle reminds me a lot of absolute value. If I were to ask you what the absolute value of something is, you would tell me it's always a positive. But the concept behind absolute value, just as an example purpose, let's say I've got negative 2 and then I've got positive 2 and then negative 2 on this side. And I say, what's the absolute value of 2? What you're doing is you're telling me what is the distance from 0 to negative 2, and you would tell me a positive 2. And what's the difference, or what's the distance between 0 and positive 2? And you would say 2. So when I ask you what's the absolute value of 2 or what's the absolute value of negative 2, I'm actually asking you how far is that number from 0 on the number line. The answer is always going to be a positive. Well, that's kind of what we're going to do for reference angle. A reference angle is how far you are away specifically from the x-axis. Specifically from the x-axis, the horizontal axis, not the y-axis, only the x-axis. So how far away are you? That's what it's asking you. So, and by the way, they use theta prime. So this, let's just say as an example, this is 150 degrees, right? So if this is 180 degrees, right, here on the hair, how far, if I'm at 150, how far am I from here to here? I am 30 degrees away. There's your reference angle. Do you see how that works? So reference angle is how far away you are from the horizontal axis or the x-axis. So here, to figure out theta prime, if it lands in quadrant 2 specifically, to find your reference angle, you take 180 minus whatever your angle is. So I gave you the example of 150. 180 minus 150 is 30, right? What if it's in radians? If it's in radians, then you just take pi minus theta. But you know what? Usually what I do is change everything to degrees and then convert it back to radians at the end. Okay? What if it's in quadrant 4? Right? I'm sorry, that's 3. 3, 3, 3. 4's on the next one. What if it's in quadrant 3? All right, well, let me give you an example using numbers. So what if this, will just say this is 240. Okay, well, remember, we want to go to the closest horizontal. The closest horizontal is up here at 180. How am I going to figure out how far away I am? I would take 240 minus 180, which is 60 degrees, right? How far away am I from 180? I'm 60 degrees away. Not a negative, just how far, right? So if you're in quadrant 3, the formula to find your reference angle is whatever your angle is minus 180. Okay? Or if you're talking about radians, it's going to be whatever it is minus pi. Okay? So that's how you find the reference angle if it's in quadrant 3. Now if it's in quadrant 4, well, now you're looking at this side over here, which is 360. Remember, you're going around the circle, right? So let's just say this is 300 degrees. How far away am I from 360? I'm 60 degrees away, right? So the reference angle is 60 degrees. So how did I do that? I simply took 360 minus theta. To find your reference angle, it's going to be 360 minus whatever your radius is, or theta is, excuse me, your angle. If it's in radians, remember what's on this side of the radians. Remember on radians, it's 2 pi. So to find your reference angle, if you're looking in radians, you're going to take 2 pi minus theta. So depending on if you're using radians or if you're using degrees, this is the formula you're going to use to find your reference angle. Now notice that we conveniently left out quadrant 1. Well, the reason why we left out quadrant 1 is because if your reference angle is here, well, let's just say this is 45 degrees. How far away am I from the horizontal? I'm 45 degrees away, right? So what happens in quadrant 1 is that your reference angle is equal to theta. And it doesn't matter if it's in degree or radians, they're the same, they're going to match. Okay, so that's why we don't really have it listed. There's no formula, it just is. So I have 2 examples, one is in radians, one is in degrees, of finding the reference angle, and then I've just got one more little thing that goes with this. We are done. I know it's so long. Oh my God. Okay, so we want to find the reference angle for the given angle. So what I would do is figure out, I would just do a quick sketch and figure out what quadrant does that lie in, and then use my formula. So remember, here's 0, we're in degrees, so there's 90, 180, 270. So where would 320 degrees lie? We would go here, maybe about here. Right? So that would be about, that's what that would be is. My question becomes, how far away am I? Remember, this was also 360. How far away am I from the horizontal? Well, I would need to go 40 more degrees to get up there, right? And so your reference angle is going to be 40 degrees. Now, if you were like, I have no idea, right? Remember, you would say, oh, okay, that's quadrant 4. So I'm going to go to my chart, quadrant 4 in degrees. I take 360 minus my angle measure. So I would take 360 minus 320, and that would also give you the reference angle, okay? 5 pi over 6, let's change that to a degree, but on my graph, I'm going to label it as radians. So this is 3 pi over 2. This was 2 pi. Also starts at 0. Okay? So I'm going to change that to degrees just because I'm more comfortable with that. Pi's cancel. 6 divides into 180 30 times. 30 times negative 5 is negative 150. Okay. So 150, but notice it's a negative, so we're actually going to go clockwise. Remember, each quadrant is 90 degrees, right? So negative would be, there's 90, and maybe about there. Okay. Now, how far away? Here I am at 150 degrees, right? How many more degrees would I need to get up to the 180? How many more degrees? Here I am at 150, right? I want to get up to the 180. How many more degrees do I need to go? Don't make this too hard. I would need to go 30 degrees more, right? 30 degrees more to get me up to the closest horizontal. Well, what is 30 degrees as a radian? Remember, 30 degrees is pi over 6. So my reference angle is going to be pi over 6. So when you have a negative degree, personally, I wouldn't use the formula. To me, it's easier for me to just say, well, I need to keep going all the way up to the 180. How far do I need to go? Get your number in degrees and then simply transfer it over to radians. Okay, so your reference angle, theta prime, should be theta prime, is pi over 6. Okay, and we can do some more of these on our Zoom meeting if you need me to. All right, last but not least, what we're going to do now is we're going to evaluate trig functions again. So we actually are going to go back to what we did at the very beginning of Unit 8, sine, cosine, tangent, all that fun stuff. So here's how it works. I want you to imagine that you have a coordinate grid, and somewhere on that coordinate grid you're given some xy coordinates. So let's just make them positive. So let's just say I'm given some positive x, some positive y, and I put that point right there. So it's some xy coordinate. What you're going to be doing is you're going to be finding the reference angle. So here's what you're doing. So here's your origin. If you draw your radius from the origin to that point, that's going to be called your R, because you have to imagine that you're just going around in a circle. If I come straight down, this is your Y, this over here is your X, and you form some right triangle. Okay? You are going to be looking for the reference angle, which is going to be this guy right here. Okay? Now, in order for you to find theta, or at least write the 6 trig functions, which is what you want to do, you've got to know what X is, got to know what Y is, you got to know what R is. So let me give you the formula for R. So the first thing you're going to do is identify your X, your Y, and your R. Okay? R is going to be equal to the square root of x squared plus y squared. It's basically the Pythagorean theorem. Okay? R is going to be equal to the square root of x squared plus y squared. So once you have x, y, and r, you are now ready to find your 6 trig functions. Remember, and then so once you know x, y, and r, you're ready to go. Find your 6 trig functions. So let me give you all 6. The sine of your reference angle is going to be equal to y divided by r. Where does that come from? Opposite over hypotenuse. Remember, SOHCAHTOA. Okay? The cosine of your reference angle is going to be x over r. The tangent of your reference angle is going to be y over x. Okay. Now, if you remember the reciprocal of sine was the cosecant. And you're just going to flip that r over y. Remember the reciprocal of cosine was secant. And that's going to be r over x. And tangent is going to be x over y, or cotangent is going to be x over y. Okay, oops. Okay, so those are your formulas. All right, so I just have 2 examples, and I believe they're both on the homework. So I'm going to leave this handy. Let me move my light a little bit here. I'm just going to leave that up a little bit. So we'll leave that slide in view, and we will go through this example here. So remember, step number 1 is identify what is x. Oh, wait, shoot, there's one more thing I wanted to tell you before we do an example. I'm so sorry. So this is quadrant 1. You have a positive x and you have a positive y, but just know that you could have different case scenarios. For instance, if your coordinate lies in quadrant 2, then your reference angle would be down here. You would have a negative x and a positive y. Down here, you would have a negative x and a negative y, and then over here, you would have a positive x. And the reason I'm telling you that is because these numbers may become negative. So for instance, if I'm in quadrant 2, anything that has an x in it is going to be a negative. So like my cosine will be a negative, right? My tangent will be a negative. That's why I'm telling you that, okay? You're going to need to know that. Okay, sorry, back up to this. So we want to evaluate the 6 trig functions, and notice that this is an example of where you're going to lie in quadrant 2. I'm going to draw the diagram. You don't necessarily need to do that, but I am just to help us visualize what we're going to be doing. Okay, so negative 3, 5 is going to go here. Now, my terminal side is going to come up here, okay? Remember, that's your R, okay? Now, if I draw my right triangle, I have the length of 3 here, I have the length of 5 here. Here's my reference angle. Remember, your reference angle is always going closest to the horizontal. So, and also notice that our x is negative. So, it says identify x, y, and r. So I know that x is negative 3. I know that y is 5. I need to figure out r, and here's my formula. My formula is x squared plus y squared square root. So I'm going to have negative 3 squared plus 5 squared is going to give me the square root of 9 plus 25, which is going to give me the square root of 34, and I'm just going to leave that. So there's r. I'm just going to leave it as square root of 34. So now I'm ready to evaluate the 6 trig functions by simply plugging my y, r, and x in. It's that simple. So sine of my reference angle is going to be 5 over the square root of 34. No, I'm not going to make you rationalize. Cosine of theta is a negative 3 over square root of 34. And the tangent of my reference angle is going to be y over x. And then I'm simply going to just write the reciprocals of that. So square root of 34 over 5. Secant of my reference angle is square root of 34 over negative 3. And the cotangent is going to be negative 3 over 5. And there you have it. Okay? Last example is on the homework as well. Now notice that they don't give us x, y, and all of that, but they tell us, instead they tell us what the sine is. Well, remember, the sine is y over r. So really, when they tell us that the sine of my angle is 3 over 4, They are telling you what y is. They are telling you what r is. So we actually do know y and we do know r. So we're going to have to find x. Once again, we can just use the formula that I gave you. We can find x using this formula as well. Okay. But then notice also the second piece of information, they tell us cosine is negative. Well, if the cosine is negative, then that means, remember, the cosine was negative meant that anything with an x, that means that anything with an x that's negative is going to make a cosine a negative. R is never going to be negative. Never, never, never. R is never negative, so it's got to be either x or y. So if cosine is negative, that means our x is going to be negative. So we know it's going to be a negative something, okay? All right, so let's go ahead and use this and figure out what x is. So we're going to say r is equal to the square root of x squared plus 3 squared. 4 is equal to the square root of x squared plus 9. So how do we solve that? We got to go back to our radical section. We're going to square both sides to get rid of the radical. And we get 16 equals x squared plus 9. Subtract 9 from both sides. Right? And 16 minus 9 is 7. That's x squared. So x is going to equal the square root of 7. Okay, now what did we say? Negative, right? So x is negative square root of 7. Now on this particular one, we just want tangent and secant. That's all we want, tangent and secant. So now we know x, y, and r. We just go to the tangent. Tangent is y over x. So the tangent of theta is y over x. And the other one we want is secant. Oh, yeah, secant is r over x. So secant is r over x, so r is 4, x is negative square root of 7. There's your answers. Okay. Whew, that's it on 8-4, guys. I'll go over some of the homework with you.